Alright guys, so we are going to go over the Unit 3 review, which consists of factoring and then some distributing going the opposite way, but primarily factoring. So we're going to start off with just kind of simplifying this. This is just asking you to distribute. This has already been factored. So what we want to do is we want to start with this term, distribute that to the inside. 3x times x will give us 3x squared. And then we also want to do that to this term. 3 times the negative 7 is going to be minus 21, and then we have the x there. So this would be what we're asking you to do for this particular problem. Now we're going to ask to factor this, and this one's just going to require you to factor out the GCF. So always when you're looking, when you're going to factor, always start to see if you have a greatest common factor first. So let's look at the numbers 15 and 5. They have a 5 in common, so I'm going to go ahead and factor out a 5. And now I'm going to look at the A's. This one has 3, this one has 1, so they have at least one A in common that I can divide out or factor out. And then my B's, I have B to the 4th and B to the 2nd, so they at least have 2 of those B's that are common with each other. And now what I'm thinking about is when I distribute this back inside the parentheses, 5 times something has to give me 15. Well, what is that something? That has to be a 3. And then we also have to think about a times something has to give me this a cubed. That would be a squared. And then b squared times something has to give me b to the 4th. And that would be b squared. Now we have, if we were to distribute this to that, what is that going to give me? Well, that's going to give me 5 times what gives me negative 5. Well, that would be negative 1. I don't have to write that. A times what gives me A? Well, that would just be A times 1. I also don't have to write that either because that's it's already there. And then B squared times what gives me B squared, and that also is 1. Since all of these, since my GCF is the negative or the 5AB squared, and that's exactly what this term is, they're all 1, and you typically don't have to write that, but since they're all the same, we do need to have something to write there, so I'm just going to put 1. That way when I distribute this, I get the exact same thing. Alright, so this is a special pattern. This is a difference of squares pattern. You can factor this if you can't recognize that by grouping or by the box method. I'm not going to do that because that would be some really big numbers. So that's when you have something in this form, a squared minus b squared equals, and it would factor like this. So you have what we have right now is something like this. In other words, I can write a term here where that entire thing is squared, and I can write a term here where that entire thing is squared. And when I do, once I figure this out and I write this out, then I can just plug in what's in those parentheses for this. So that would be a plus b and a minus b. So let's think about this real quick. If I start off here and I'm trying to get something for the 16, what's the number that I can square to get 16? Well, that would be a 4. And then what's the number I can square to get x squared? That would just be an x. So if I square this, that gives me 16x squared. And then what's the number if I square I get 9? That would be 3. So here's my a, here's my b, and then I can plug those in. A plus b, a plus b, a minus b. So my a is this 4x plus b and 4x minus b. That's this factored. You can always factor that too by grouping or by the box method. Here we have just a normal trinomial. I'm going to factor this by using the box method. What we need to do is we need to start by multiplying. Any type of method like this, you need to start by multiplying a times c. So in this example, a times c is going to be 1 times 60, which is 60. So a times c is 60. And then I'm going to make a factor tree. But if you get pretty good at this, then you can recognize right off the bat that negative 10 times negative 6 multiply to positive 60, and they add to negative 16. So if I'm using the box method here, I'll use the box method on one and I'll use grouping on the other. If I'm using the box method here, my leading term goes up here always, and then my c term goes down here in the bottom. And then I'm trying to figure out what goes here and here. And that's what I just did over here on this little factor tree that I circled. So I'm going to start by writing the negative 10 and then the negative 6 right here. And we also need to make sure that whatever we added, like the letters or the numbers in green, negative 10 and negative 6, we are going to bring this sign out. So since that's a negative, I'm going to put a minus right here at the top of this, and then I'm going to put a minus over here on the side of this because this is also a negative. If one of those are positive, we'd do the positive. Okay, now the way the box method works again is we're going to follow. We're going to factor out we're going to determine what the GCF is of each row and each column. It doesn't matter what order. It also doesn't matter what order we write those in. We could have put the negative 6 up top and the negative 10 in the bottom. So let's look right here first. I have an x squared and a negative 6x. Well, if we think about the numbers, 1 and negative 6, they only have a 1 in common. So you can write that. You don't have to. But then look at the x's. One has x squared, one has x, so they have at least an x in common. So I'm going to write that GCF there. Now let's look at 10x and 60. The number 10 and the number 60, the largest thing that could divide both of them would be 10. 60 does not have an x in it, so I won't have an x to factor out. So that was looking at this column. Now let's look at this row. So here, 1 and negative 10 only have a 1 in common. We don't have to necessarily write that. And then x squared and x, they have at least one x in common because one of them has 2 and the other has 1. 6 and 60, the largest thing to divide both of those would be 6. And our factors are written for us right here on the top of the rows and the top of the columns. We just have to get them to look like factors. So now we just need to take these and write them out and put them in parentheses. So my answer would be x minus 10 times x minus 6. And if I redistributed that all using FOIL, I should be able to get where I started by distributing that. So the first is x squared. And then I have the outside, which would be here and here, which would be negative 6x. Inside, which would be negative 10x. And then last, which would be positive 60. When I add my middle terms in the middle, I get this, which is exactly where I started with up here. Okay, let's do factor by grouping on this one, since I did the other thing on the last one. So we're going to start by multiplying a times c, which is negative 20, and we're going to list the factors of negative 20 that add to positive 8. That would be positive 10, and, well, I'll go ahead and list the factors of negative 20. So I always start with 1. This number is negative, so each one of these numbers need to be positive or negative. So I start with 1 times negative 20, and then I switch negative 1 times positive 20. And then I see that 20 is even, so also 2 can go into that. 2 times 10, or negative 10, and then negative 2 times positive 10. I have 4 times negative 5, and negative 4 times positive 5. These are all the numbers that can divide evenly. On your TI-84, if you're having problems with this, you can always go to y equals and type in whatever your a times c is over x, and then so that would, in your calculator for this example, you would type in negative 20 over x under y equals, and then you would go to the table. So hit table, and then you're looking for the columns of xy that have integers, that have whole numbers. Those would be factors, and if you look at that, you'll see all of these numbers show up. Everything else will be a fraction or a decimal. So these are the factors of negative 20. Now what we're looking for here is the ones that add to this middle term. So I can rewrite this middle term. So if I add these together, my middle term here is positive 8. So if I add these together, this gives me negative 19. That gives me positive 19. This gives me negative 8. This gives me positive 8. And I can stop there because that's what I'm looking for. Okay, so I'm going to rewrite this. So I have negative 10, positive 10. I'm going to clear my screen. So I'm rewriting this. I have x squared plus blank x minus 20. So what goes in the blank? We need to remember, make sure you put the x's in there. That's going to be positive 10 and negative 2. So I'm splitting, I'm rewriting this. If I add those together, I get the same thing. So once I have this, I have 4 terms now, and I group. I group my first 2 terms, and I group my second 2 terms, and now we factor out the GCF of each group. What's common between those 2 terms will just be an x. And then if I'm dividing out an x, then x times x will give me this x squared. X times 10 will give me that 10x. Now I look over at the next group, and I say, okay, well, negative 2x and minus 20 have what in common? Just like when we did the box method, this number right here, if that's negative, I'm going to factor that out with it. So they have a 2 in common, but I'm going to say that that's a negative 2 because there's a negative sign in front of that 2x. And then I do the same thing. Negative 2 times what is going to give me negative 2x, and that would just be x. And then negative 2 times what is going to give me negative 20. That would be a positive 10. Once you get here, these should be the same. So that's going to be one of your factors. And what's on the outside is going to be the other one. So you can just put those in parentheses. X minus 2 is going to go together, and x plus 10 is going to go together. And those are our factors. And you can distribute that to check that yourself as well. We're going to skip this one. Here is another difference of squares pattern. You can always factor this by grouping or the box method too. Let me show you what that would look like once again. So here we don't have a middle term, so for placement we can say that that's 0x. And if I did a box right here, I would have my x squared term here, my negative 49 here, and I would multiply a times c, which is negative 49. List the factors of that. And so 7 times negative 7 is a factor of negative 49. That also adds to my middle term, which is 0. So this is what I would fill in here and here. You can list the other factors. There's pretty much only 2 more, 1 times negative 49 and negative 1 times positive 49. But here we would factor out the write the GCF of each row and each column. So here I have a GCF of x. Here I have a GCF of a negative 7 because 7 is the largest thing to divide 7x and 49. We need to move that negative out. So we factored out that GCF. Here, x squared and minus 7x have an x in common. And here 7 and negative 49 have a 7 in common. And since this is a plus 7, we're going to put a plus sign between the two. Now we write these out as x minus 7 times x plus 7, and that's our answer. When we redistribute this, that's x squared plus 7x minus 7x minus 49. The middle terms would cancel out and give us x squared minus 49. So that's how you would do that if you were factoring by the box method. You can also think about this. This fits the a squared minus b squared pattern. We have a minus sign between the two, and both of these we can write as something squared minus something else squared, which would be just this. A plus b, a minus b. So we can write it like this. So let's think about that. What would we have to fill in the first parentheses to have it something squared? So we want the first term to be an x squared. So if I have an x in here and I square it, then that gives me x squared. The next thing is I have to find something that I can put in these parentheses that I squared. It gets me 49. Well, that would be a 7. So if I fill these in, this is my a, this is my b, and I write this out, that would be a plus b times a minus b. So x plus 7 times x minus 7 is exactly what we just found a second ago. So that is that shortcut for factoring difference of squares. This also is a special pattern, but I'm not really going to go into it a whole lot. We're going to factor this by the box method. I think the box method is traditionally a little more popular with students. So box method, start off by writing our first term and then our last term. 121 is a kind of a big number, but if you remember your multiplication tables, you should know that 11 times 11, or 11 squared, is 121. And so when I'm doing my a times c to get to 121, I know that 11 times negative 11 negative 11 times negative 11 multiplies to positive 121. And also adds to negative 22 because our middle term, our b term, is negative 22. So this is what I would write in my remaining square. So this would be a negative 11x, and this would be negative 11x. I'll color code those. Negative 11x minus negative 11x. So from here, we do the same thing. We write the GCF of each row and each column. Make sure we move the negative sign out here and the negative sign up here because those are both negative. Now the GCF of this first column is just x because x squared and negative 11x have an x in common. The next one, 11, can divide both itself and 121, so that's going to be negative 11. Here, that was this one. Now let's look at the row. X squared and negative 11x have what in common? Well, they both have an x in common, and that's it. And then negative 11x and 121 have an 11 in common. So our factors are written right here. That's x minus 11 times x minus 11, which this is fine, but that's not completely simplified. That's the same thing as this. If you have two of those, we can write them as that, since they're the exact same thing. Okay, I'm going to factor this one by the box method again. Let's see. So my first term, first of all, we haven't had any that have had this, but we always want to make sure that we factor out a greatest common factor. If there is one, there isn't one here. So I'm going to put 4x squared and a 9 right here, and I'm going to figure out what's going to go here and here. So here I'm going to make my factor tree. My factor tree is a times c, so I'm looking for factors of 36. So a times c. And I'm looking for the factors that add to b. So I always start with ones. So 1 times negative, sorry, that's a positive number. So 1 times positive 36, negative 1 times negative 36. I also have, let's see, 2 times 18, negative 2 times negative 18. I have 3 times 12. There's a lot of these. Negative 3 times negative 12. 4 times 9. Negative 4 times negative 9. And then I have 6 times 6 and negative 6 times negative 6. So there's a lot of these factors. If I add them together, this would give me 37. This would give me negative 37. This would give me 20. This would give me negative 20. This would give me 15. This would give me negative 15. Give me 13. Give me negative 13. This will give me 12. This will give me negative 12. And what was my middle term? My middle term was negative 12. So the very last one that we get gets us at negative 12. So that's what I'm going to write in here in the box. Negative 6 and negative 6. Remember to factor out your signs with these since they're both negative. Now we're going to look at the GCF of each row and each column. 4x squared and 6x. The largest thing that can divide both of those is a 2 when I look at the 4 and 6. So I have a 2. And then x squared and x have an x in common. Now I'm looking at 6 and 9. The largest thing that can divide both of those is 3. And since 6x is the only thing that has an x and 9 doesn't, this will be my GCF for that, for this column. Now let's move on to this row. 4x squared and 6x. Well, the 4 and 6 have a 2 in common. And then we both have an x as well. And then in the bottom one, they both have a 3 in common. And so this would be our what our factors are. Just put them together. 2x minus 3 times 2x minus 3, which is also the same thing. So this is correct, but this is also the same thing as 2x minus 3 squared. Kind of like that last one I think we did. And then lastly, let's do the box method again. Start off by putting your 3x squared up here at the top and minus 6 down at the bottom. We're looking for what goes in here and here. So I'm going to start by making my factor tree. I'm going to multiply a times c, which would be negative 18. And I'm going to list my factors of negative 18. I'm trying to find what adds to negative 7. So this is a times c. This is b. So I'm going to start with 1 times negative 18, and then I'm going to do negative 1 times positive 18. 18 is even, so I also have 2 times negative 9, negative 2 times positive 9, and then I have 3 times negative 6, and negative 3 times positive 6. And that should be all the factors. If we add those together, if we add all these together, that gives us negative 17. This gives us positive 17, negative 7, positive 7, negative 3, positive 3. I'm looking for what adds to negative 7, so let's circle those, which would be these. And I'm going to fill in those numbers in for these here. So that would be a 2, and this would be a negative 9. It does not matter what order you write those in. And now we're going to write the GCF of each one of those. So here, the sign has to be negative. Since this is a plus 2, we're going to put a plus there. 3 and 9, the largest number that can divide those is 3, and then they both have an x in them. One has 2 and the other has 1, so they have 1 in common. 2x and 6, the numbers 2 and 6, the largest number that can divide both of those is a 2. And 6 does not have an x with it, so you can't have an x for GCF. And then 3x squared and 2x, the largest number that can divide both of those is just an x, a 1x. But you can just write an x. And then 9 and 6 both have a 3 in common. So these are our factors written out. You just need to write them to look like factors now. 3x plus 2 times x minus 3. And that is our answer. Once again, you should always be able to redistribute this and get where you started. That would be negative 9x, this would be 2x, and then this would be negative 6. When we combine our like terms in the middle, we get 3x squared minus 7x minus 6, which is exactly what we started with. And that is our factoring unit. Good luck, guys, and we'll see you next time.